Researchers at South Korea's Ulsan National Institute of Science and Technology, or Unist, have unveiled a multifunctional 멤리스터 made from a two-dimensional semiconductor. What is a semiconductor like this, and why is the technology drawing so much interest from scientists worldwide, especially in advanced computing and memory devices? Why have computers traditionally separated memory and processing? Most modern smartphones and computers operate based on the von Neumann architecture. Associated with mathematician John von Neumann in the 1940s, this design keeps memory, which stores data, separate from the processor, which performs calculations. For example, when you edit a photo, the image is first retrieved from memory, processed by the processor, and then stored back in memory. As semiconductor technology advances, however, moving data between memory and the processor has become a greater challenge than the calculations themselves. Even if processors become faster, overall performance cannot improve significantly if retrieving data takes too long. This limitation is known as the von Neumann bottleneck. In addition, constantly transferring data consumes large amounts of electricity, creating heat and increasing power consumption. Memristors, devices that remember electrical signals. Among the most promising answers to this challenge is the memristor. Its name combines the words memory and resistor. Unlike a conventional resistor, which cannot retain information about earlier electrical current, a memristor modifies its internal state as current flows through it and preserves that state even after the power is switched off. Because the stored information is retained without electricity, a memristor can function as memory. At the same time, it can use that stored state to perform calculations, allowing data storage and computation to occur within the same device. Two-dimensional semiconductors make multifunctional chips possible. This breakthrough is made possible by two-dimensional semiconductors. While these materials are just a few atoms thick, their value extends far beyond their thickness. They allow electrical current to be controlled with exceptional precision, and different layers can be stacked to create properties that conventional semiconductors cannot easily achieve. Since the 1940s, the von Neumann architecture has shaped modern computing by keeping memory and computation separate. More than 8 decades later, that defining feature has also become one of its greatest constraints. Interestingly, today's research is moving toward computers that process information more like the human brain, where memory and computation occur together. Memristors are considered one of the leading technologies for mimicking the brain's synapses. Researchers are now watching closely to see how far multifunctional semiconductors can transform the way future computers process information.